Here we have another set of examples where we are evaluating logarithms. We introduced the idea and the definition of a logarithm in our first video for our Module 5.2 class notes. Here is that definition again. Y equals log base b of x is equivalent to b to the y power equals x. And I also mentioned in that video for examples 1 through 4 that a logarithm is a power. If y is the power in that definition and y is equal to the logarithm, then a logarithm is a power. And that's the most, pardon the pun, the most powerful way and simplest way to think about logarithms. Let's see that in action here, starting and going through all of these examples, but let's start with what I consider to be the simplest one, which is question number 10, log base 2 of 4. We have a base 2, a result of 4, to use the same vocabulary that I used in my first lecture video for Module 5.2. We have a base of 2 with a result of 4, and the question here is, what is the logarithm? In other words, what is the power? What is the power that we have to raise a base 2 to get 4? And of course, we know 2 to the second power is 4, so the logarithm is the power 2. 2 squared equals 4, so log base 2 of 4 is 2, the power that we have to raise the base to get that result. Let's look at another one and let's skip back up to question number 7, where we have log base 4 of the 7th root of 4. So the question is, what power of 4, base 4, what power of 4 gives you a result of the 7th root of 4? So the 7th root of 4 is what is 4 to what power? The 7th root of 4 is 4 to the 1/7 power. The 7th root of 4 is 4 to what power? The 1/7 power. That's all a logarithm is. You've got a base, and you've got a result, and the question is, what power does the base have to be raised to get that result? Let's practice again, moving up to question number 6, where we have log base 2 of 1 over 32. So we've got a base 2 to some power has to give me a result of 1 over 32. So 2 to what power gives me a result of 1 over 32? 2 to the -5th power gives me a result of 1 over 32. That's the power that I have to raise the base 2 to get a result of 1 over 32. So that is my answer. That is the logarithm. A logarithm is a power. The answer then to question number 6, to example number 6, is -5. Skipping down to question number 9, here log base 14 of 1. That is, 14 to what power will give me a result of 1? 14 to what power equals 1? Of course, anything to the 0 power is 1. 14 to the 0 power is 1, so my answer is the logarithm is the power 0. 14 to the 0 power is 1, so log base 14 of 1 is 0. Back up to question number 5, and the question here is a base, so log base 121 of 11. Base 121 to what power gives me a result of 11? I have to figure out 121 to what power gives me 11. And if I remember correctly, I think the square root of 121 is 11. In other words, 121 to the 1/2 power is 11. So a base of 121 to a power of 1/2, which you know means a square root, gives me a result of 11. So my power then, my logarithm, is 1/2. And finally, in question number 8, log base 3 of -9. 3, base 3, to what power gives me -9? 3 to what power results in -9? And that is a trick question, because no matter what power I raise 3 to, I'm always going to get a positive answer. 3 to any power is going to be a positive number. I can't raise 3 to a power and get a negative result. I can't raise 3 to any power and get a negative result. That is impossible. That doesn't work. So we say that that logarithm is undefined. You can't have a negative result in a logarithm. You can't have a log of a negative number. For that matter, you can't even have log of 0, because I can't raise 3 to a power and get 0. That actually brings in some domain restrictions for logarithmic functions that we will look at. But for now, suffice it to say, our first example where we start to realize that logarithms are restricted in some ways. You can't take the log of a negative number. You can't take the log of 0, because the corresponding exponential doesn't work. All right, more to come, examples of evaluating logarithms.